Hello friends, let's start with the solve example today. We will see some examples which is asked previously in IIT JEE as well as CBSE board exam. Okay, so this is the last part of this video. We'll see some important numerical here. Let's start with the first problem. Let's start with the question first. Check the correctness of the relation s equal to ut plus half at square, where u is the initial velocity, a is the acceleration, and t is the time, and when s is the displacement. So we need to prove whether this is correct or not. For this correctness, first of all, let's see LHS, that is equal to displacement. So it is displacement. So as you know that displacement will have the dimension as a L, right? And remaining other term will be 0. So we have LHS with us. Now let's talk about the RHS. So for RHS, let's start one by one. As we have already discussed, the dimension of addition must be same. What I'm trying to explain, if it is ut is there, so whatever the dimension of ut, that must be equal to half at square. Even half will not have any dimension since it is a constant. So let's talk about the RHS. RHS is u into t, so velocity into time. So velocity will have L t inverse and time will have t. So overall we'll get L here, that is correct, right? Let's check for the remaining half portion of the RHS, which is half at square. So half is there, so half will have no any dimension since it is a constant term. A is the acceleration here, so it will have L t raised to power minus 2. T square is there, so t square, it means it's a t square will remain t capital T square. So at overall, this t raised to power minus 2 and t raised to power 2 is there. This will get cancelled. We'll have the L as a remaining term, so we'll have this answer. Okay, got it. So I hope this is very easy question. All of you have got this. Okay, so let's talk the second problem now. That the dimension of A and B in the relation which is given. Guys, this is very important type of problem. Okay, this is most asked question. So guys, this is very most important question, keep in mind. Okay, let's start with the question here. So there it is, p is equal to b minus x square upon at. P is in power, x is in distance or displacement, t is in time. So let's check this p. At is there, a and t, so this at will get multiplied here, so at last we'll get b minus x square. What will be the advantage, like if the b and minus x square is there, so both of this is getting adding or subtraction will be there. Whenever it is addition or subtraction, it means it will have the same dimension, right? So we'll get an idea like that b will be equal to dimension of x square, and x is nothing but the displacement or distance. So distance will have the L, since it is a square, so it will have L square. So we'll get an idea that b will have the dimension as a L square. Okay, now even it is equal to PAT, right? So if PAT can be equated with this x square or like L square, so from there we'll get A as a x square by PT. P, that is power, will have the dimension ml2 t raised to power minus 3. How did we get that? That is work done upon time. Work done is force into displacement, and this time is capital T. Okay, so we'll have the A as a m inverse L raised to power 0 t raised to power minus 2. Okay, got it, friend? I hope this is very easy. Okay, let's check with the next problem. This question is taken from the NCERT. Let's check the centripetal force is there acting on a particle moving with the uniform depends upon mass, velocity, radius, and derive the formula. Let's see the formula. As you know that F is directly proportional to mass according to the question. It is directly proportional to the mass as well as the velocity as well as the radius, but they have not given the power. We need to find the exact formula. How we'll find this? Let's see the mass raised to power is x, and let's see v raised to power y and r raised to power z. Guys, you may have listened some sound due to this. There is a festival over there. Sorry for some noises which you are able to see. So please focus on the study as you used to focus on your classes. Even some of the time you find it like there's some noises coming in the schools as well, but we have to focus on the exam. So sorry for that noises. Okay, well, let's come to the point. So f is there, f. So f will have the dimension mlt raised to power minus 2. Okay, that is great. Now let's see this, keep this constant. We know that reactive proportionality, to remove the reactive proportionality we require a constant that, let's say this is k, m raised to power x, v raised to power y, and r raised to power z. So a mass is there, so this will be represented by capital M. Lt inverse is there. This is because of velocity, and this radius distance is L raised to power z. Let's see how many the term of m raised to power x is the single term. What about the Lt inverse? Lt inverse, so we'll have the only two terms for L is there, so L raised to power y and L raised to power z. So two term is there, L raised to power y and z, right? So keep this as it is. What about the t will have only single term, t raised to power minus 1. Any other term? No, we don't have any other term. So t raised to power minus 1 into y, so we'll get t raised to power minus 1. Got it? Well, so now last step is on equating the terms. So m raised to power 1 is there on LHS. Here we have m raised to power x. So we'll get, on equating we'll get x is equal to 1, because here m raised to power 1 were there, m raised to power x. On equating we'll get x raised to power 1. On the same way, if you get the like L, so L in LHS again it's 1, L raised to power 1 is there, or in RHS we have y plus z. So the equation will become now y plus z is equal to 1. Let's come to the last part, which is L raised to power z, t raised to power minus y, and there we have t raised to power minus 2. Okay, so t will have the value that is directly, you can write y is equal to 2. So you can place this value x and y in this equation, and we'll get this. At last we'll got all the values x, y, z. Finally we need to put the value. We'll get f is equal to k mv square by r, and according to this experimental value we know that k is equal to 1. Okay, got it? Well done. So let's come to some more important problem, like write down the number of significant figure. Guys, we have already discussed about the significant figure in the theory. If you have not watched this, so go to the previous videos. Just please watch this video. You must get the clear idea regarding this. Okay, let's start with the significant figure. How many significant figure will have? Like, let's see, this is 6428. So how many significant figure will be there? There will have the 4 significant figure, because each term is separate term, right? If you're talking about this, so again 62.00. so there after decimal there's single 00 is there, so it will be counted, guys. So it will be again 4 significant figure for this. But remember one thing, if before the decimal, if we'll have no single any like number greater than 1, like greater than 0, like, so this remaining 0 will be not be counted. What I'm trying to explain, like if it is talking about the left side of the decimal, so it will have some fixed value like 1, 2, 3, whatever, greater than 0, 1. Okay, so the right side 0, whatever it will come, that will be counted. But whenever the left side of 0 will be not greater than 0, so that will be not counted as a significant figure. I mean, like this remaining 2 zeros will be not counted as a significant figure. Okay, so here it is the 628 will be counted as a significant figure. Well, let's see the 1200, guys. 120 is again the same way like 6428. So again it is a normal, it will have 4 significant figure. Now let's see the next problem, which is of round of 4 significant figure. So let's see 45.689. let's see, guys, if you'll see 9 is the term which is greater than 5. So preceding one of the 9, which is 8, now that will be incremented by 1, so the round of figure will be 45.69. If you're talking about 2.0082, so the last term is 2, preceding which is less than 5, so preceding one of this 2 will be remain as it is. I mean, like this will be remain 8, so that is the round of figure. Let's talk about the next problem, which is 6.1. Add this 6.75 into 10 to the power 3 centimeter, 4.5 into 10 to the power 2 centimeter. Guys, you have to remember whether both will have the same SI unit or not. In case if you'll have no like the same SI unit, we need to first convert it, then we'll need to add this or subtraction, whatever it is. Okay, now in this question the SI unit is same, so no need to conversion, just directly addition. Let's see how we'll add this. Okay guys, let's see. Here is this is the first term, which is 6.75 to 10 to the power 3. This is the second term, p is equal to 4.5 into 10 to the power 2. Finally we need to add this. So for that, what we will do, we will just try to make this 10 to the power 2 as a 10 to the power 3, because the addition will become easy, because the first term is 10 to the power 3, so we will try to make the second term as well 10 to the power 3. Okay, so this 4.2 can be written as 0.452, and this will become 10 to the power 3. So the addition will become easy. The 10 to the power 3 in the b term and the full first term a 10 to the power 3 is same, so we can write this as a 10 to the power 3. Now let's do the addition. So we'll have 6.75 in a and 0.452 in the second one. Okay, so you have to just remember one thing, that up to 2 places of decimal we have to consider. Why up to 2 decimal? We have to check, while addition or subtraction, we have to check the least number of decimal after the least number of values, least number of number, okay, after the decimal. There it is 6.75, I mean like after decimal there is 2 term, and in this situation after decimal there is 3 term. So we'll have to take up to 2 term only, least number, so which is 275. So the answer will be now 6.75, 0.45. Just ignore this 2. So since it is 2, so the preceding one will be remain as it is, which is 5. So finally the addition will give us 5 plus 5 will give you obviously 10, so 0, 7 plus 4 9, right? 7 is there. Okay, got it. 7 plus 4, which is 11, or plus 1 preceding one, that is 12. So carry 1, 6 is there and 0 is there, so it will be 7.2, 10 to the power 3 will remain as it is. Got it. Let's come to the next problem. A thin wire has a length of 21.7 centimeter and the radius is 0.46 centimeter. Calculate the volume of the wire connected. Correct significant figure. Let's start with this. The length is given, radius is given, so we will know that the volume. So what will the volume? Since wire is nothing but the cylindrical form, so it's nothing but having the formula pi r square h. H is the length, right? Height, length. So here is the length, so pi r square l. Pi is there 22/7, radius is there 0.46, right, which is in millimeters. So first of all we need to convert it into the centimeter, so we'll get 0.046, right, divided by 10 will be supposed to give us centimeter. Then this keep this centimeter as it is, so finally we'll get the value, which is 0.1443 centimeter cube. Guys, let's see. As you know that the multiplication rule, so with the help of this we'll consider up to what, 0.14 centimeter cube. If you are not able to check this, refer the previous video. I just give you a little bit better rough idea, so you'll get the better idea how I just neglect this. The reason behind it is very easy. What I did, the result is rounded off at least number of significant figure in the given measurement, that is 2. If we'll see, the least number of measurement is 0.046, right, but the previous value of left hand side is 0, so we'll not count this as a 0, so we'll have the 46, which is 2 number, so we'll just make it up to 14. Okay, got it. Let's do the problem on error and absolute mean error example. Let's read the question now. The refractive index of a glass is found to have the values 1.49, next is 1.50, next term is 1.52, then after 1.54, and then we have 1.48. Let's find now. Calculate the mean value of the refractive index. We need to find the refractive index. Okay, so we'll have the very easy. For mean value is nothing but the average. We need to find the average, so just add the value and finally divide it by number. Count the number 1 2 3 4 5, so 5 is there, so just add this by 5, so I'll get the value like 1.505. Just as we know that for addition or subtraction we need to count the least number, which is after the decimal, right hand side of the decimal. So there is a 50, right, 52, 54, 48. So this is 2 values are there, right, so we'll keep this at to 1.51. okay, round of 2 decimal. Let's find the second part, that is mean absolute error. For mean absolute error, what we need to do, we need to just subtract the value by the mean. So mean is 1.51. What is the actual value? That is 1.49. Just keep this here, so we'll get this much value. The mean value 1.59. The next value, which is 1.50, so we'll keep this as it is, we'll get this value. Okay, same way we'll consider the mean value and the subtraction with this value, so on we'll get the value. Now we need to find the mean absolute value. For this we have to do the same step like the mean value which we did earlier step, but the only difference will be we need to consider the mod here. So we'll take the mod of all this value, find the mean value. Next we need to find the mean absolute error. For mean absolute error, let's do the mean absolute error. Here is the mean for mean absolute error. We need to just add all the value and this divided by 5. Last part is fractional error. For fractional error we have formula plus minus of mean upon nm. Okay, so this is the mean value. Now this is the nm, which is actual mean value, right? So just divide it and we'll get the value. The last step is percentage error. You need to just multiply it by 100, we'll get the percentage. Got it? Now come to the next problem. The radius of a sphere is measured to be 2.1 plus minus 0.5. This type of problem is asked in examination, plus minus 0.5 centimeter. Let's calculate the surface area with the error limit. Okay, here is the surface area is equal to 4 pi r square. First of all you have to remember that the formula, the surface area of a sphere is 4 pi r square. Now do the just put the value. So 4 is there, pi 22 by 7, whatever the radius. So in this case radius will have be 2.5. okay, so we'll get this value, the exact kind of value. Now plus minus 5 is nothing but the error. Either it will be plus 0.5 or minus 0.5. So use the concept, if you remember, del s by l. 4 is a constant term, so no need to do that. Pi is a constant term, no need to do that. Whatever the power, r square is there, whatever the power, this power will get multiplied here. So it is power is 2, so 2 will get multiplied. The last step will be del r by r. R is there, so del r by r. Okay, so del s we need to find that the surface area error limit. Okay, del r by r, let's put 2 as it is, del r, the change in r, right, that is 0.5. What about the r is the exact value, that is 2.1. Here is the s we just find it at 55.4. we just put that value, we'll get the value is like 26.4. so this 26.4 will be added to the surface area, which was earlier 15.4, and this is plus minus 26.4. so basically, if the area, what type of question was that, let's see. According to them, the question is like the radius may vary from 2.5 plus minus 0.5 centimeter. So accordingly, how is going to the surface to be supposed to be changed? So we find the exact area first, then we find, using that method, we find the errors. So this is the error 26.4. This may be get either added or subtracted. So this will be your answer. Okay, got it? Clear? No problem, guys. I hope it is clear. Let's see the last problem of this, then we have the answer at the corners. Okay, so let's see the 10th problem now. Calculate the focal length of a spherical mirror from the following observation. Here is the object distance, u is given 50.1 plus minus 0.5, and the image distance v 20.1 plus minus 0.2. Use the formula. We have to first of all remember the formula, 1 upon f equal to 1 upon v plus 1 upon u. Since it is mirror, so it will be plus. If it is lens, then it will be minus, right? Somehow you find the f, so f will be like the exact value. Okay, like the preceding one, the preceding question. Now the next step, f to del f by f plus minus. So u by v, you must have an idea regarding the if you check the previous video, you will find it. U into v is there, so you'll just do del u by u. For v, del v by v, not the divided part, the division part, the denominator part, that is del u plus v, just a normal addition. So for this you need to do this delta u plus delta v upon u plus v. Got it? Finally you just have to put the value, you will get this. Okay, and at last we will get this, f will get multiplied here, and we will get this as a change in f. At last we will put this value, f is there and this change in f is there, so we'll put this value and we'll get this as answer. Okay, so guys, let's complete this video. If you like this video, please comment me on the comment box given below. Please subscribe the video if you like the video, because I'm going to put some more video in this channel. So okay, thank you for watching. Best of luck, guys.